we go again with another video from my workshop. This time I'm working on a Bernoulli box, a dual, what do you call it? Bernoulli box dual, I forget what the name of it is. You probably, if you look for Bernoulli boxes on other YouTube videos, you probably saw some of these in action. This is one of a few that I got from a pickup not too long ago. These are two 20 megabyte Bernoulli boxes. They use the 20 megabyte cartridges, which actually look like the other cartridges that are available for the later Bernoulli boxes, the 44 megabyte, the 90, the 150, and the 230 megabyte, but these are specific for these 20 megabyte boxes. And I have it open now because I've been trying to figure out, once you take it out, you can't put it back in until power's applied. I'm trying to figure out how to get these to read. I have a system here that I can boot to Windows, and I got it to work on Windows. It's not that good, but I also have a USB drive in the back, and I'm going to boot it into Linux. Hopefully this won't mask out my voice when I power this up. But I'm going to show you how these things can run on Linux. Meanwhile, while it's booting up, because it'll take a little bit of time, and I'll be dropping back into this every once in a while as it boots. It takes a little while to boot off of the USB because it's an older Pentium system. I'm actually using Yumi, I think it's called Yumi, to create multiple boot environments, multi-boot USB. So I have a couple Linux distributions on here to choose from. Yumi's nice, especially if you want to boot from different ISOs, bootable ISOs. Yumi will put all the ISOs onto your USB drive until you fill up all the space, and then you can boot to any one of them. I found I'm using Ubuntu 6. I can use pretty much any of these Ubuntu versions, and it should pick up the Bernoulli box, but I'm picking an older version just because I'm going through a PCI SCSI card, and I'm actually directly connected to the drives. These older Bernoulli boxes have a 37 pin, I call it a DB37. That's sort of a misnomer from what I understand. It's not really a DB37, but it looks like a DB9, DB15, that kind of stuff. But anyway, I'm going to boot off of Ubuntu here. And while this is booting, there's a few things I need to set up as it starts. But in the meantime, I'll show you a few things. Hopefully it'll show up in the video here. If not, I'll move the camera closer to it. You notice there's two drives in here, but one of them is populated with more electronics. And the cable comes into a 50-pin kind of a SCSI connector. Hang on a second, I'm choosing the non-persistent boot. And then from this, it normally would go to this cable, which goes to the second drive. So this is sort of a primary drive, and it is pure SCSI. This one is a secondary drive, but it is, I'm going to go ahead and turn this on while I'm at it. Switch. Where's the switch at? But this doesn't have all the electronics, so these work in pairs. But this is an actual SCSI drive. It has a terminator already built into the board. Hang on, I'm going to continue this boot up here. I have to set up certain boot options because this screen is just an old television, and if I let it boot into native mode, video mode, the television is not going to pick it up, so I have to force it into another mode. And another thing I want to do in the boot options for this is I want to get rid of the quiet and splash boot parameters so I can actually see what it's doing when it's booting up. So that'll take a little bit of time. So these are SCSI. Now, they originally had a controller that would go into, I believe, an ISA slot. I don't think they had a PCI version of it. It's made by Iomega. And it would use a 37-pin cable to go between them. But it is still SCSI. It's just they wired it up their own way. I found that I can take a direct SCSI ribbon cable from a standard SCSI card. I have an Adaptec card in here. And I tried first going into where this one goes in the back of this drive, and it's not completely compatible. However, it is compatible to where this went into to go over there. So I just popped this off and put that on. So this will read as a SCSI drive. And actually I could probably put any kind of SCSI drive in here, a CD-ROM drive, a hard drive or whatever, and this hardware will work for it because it uses the standard 4-pin power connector. And well, we're still on. I told you it would take some time. But what's going to happen is, as it loads, it's going to detect the SCSI card, which is what I needed. It was hard to do that in Windows, and I booted Windows 95, I believe, off of this before, because these systems, these Bernoulli drives are old. So I wanted to boot from an older operating system that where if I need to get drivers, at least I know I have drivers for that operating system. And this machine's just too slow to run Windows 10. And I got it to work with Adaptec drivers. This picks up just like any other SCSI drive, and all of its electronics know how to handle its own media. So it looks like a CD, SCSI CD drive. Just there's a little more to it. Now, as I said, these are 20 megabyte cartridges, and they were designed for this system. In fact, I'll go ahead and put this in a while, and you'll see it starts to spin up. That little click you heard was a pin popping down. This is like an electromechanical pin, and it has basically locked this in place. I can't pull this out. I actually have to unmount this disc to do it. Okay, now we're starting to load stuff. I don't know if you can see anything in here. Okay, so there's the SCSI subsystem initialized, and you know what? There's going to be a problem here. This is going to. Okay, so there's the SCSI Adaptec SCSI driver, and there it found the Iomega, the Beta 20i. That's what this is, and it's trying to mount the device, treating it as any other drive. And I'm still working with this, and it's picking up all the other hard drive stuff in here. I actually have one in here. I have a bad IDE hard drive that I left plugged in. That's probably why it's taking so long to load, because it's trying to read a bad drive, and it's doing that until it times out. So that's just going to extend this video if I don't, edit this portion out in the first place. And there's also this particular motherboard on here is an industrial computer motherboard. It has an onboard CF or compact flash slot right on the motherboard, and I have a card in there too with some stuff. You can see I'm getting some errors. HDC, that's the one drive that I was telling you about. It also picked up the 256 megabyte compact flash drive. Let's see, HDC cache flush is not supported, failed opcode. Well, that's not what I'm worried about right now. I'm booting off the USB drive in a runtime Linux environment, and I want to read this. So, okay, it's going to keep doing things for HDC, which is the 256 megabyte, and I'll just let that go. Meanwhile, as we're going along, I got these intending to get them working and selling them at the consignment at the Vintage Computer Festival East show, and I did not have time to get those done. But to give you an idea of some of the other ways that these came, you can also get them in this format. It looks like a big old external SCSI drive, but it's a Bernoulli drive. This one is an actual 20Z, which can read these same discs. And I've had this hooked up, and the problem I had with this one, which I believe I'm also having with this, is that for some reason the operating system this was hooked up to before treated it as 256 byte data blocks on the disk. So what does that mean? Most standard drives that I'm aware of in Linux, Windows, or whatever use 512 bytes per block on a disk for a sector. And this is not formatted that way. This is actually formatted with 256 bytes per block. And because of that, the fdisk command in Linux has a hard time working with it. It actually crashes the fdisk program because it's expecting to see a standardized 512 bytes per block. But when I run other fdisk style programs, it tells me that it's the partitions are there, but it's only a 10 megabyte partition, which I think it gets at because 256 is half of 512, so half of 20 megabyte is 10 megabyte. Okay, here we go. We're finally into the operating system. Another issue I have to deal with too is that these old TVs make horrible computer monitors because they turn on overscan by default. So everything goes off the edge, and I can't turn this off, so I just have to kind of guess where things are at. But I'm going to open up a terminal here. I don't want to do that. Applications, terminal. All right. And I'm using one of these combo keyboard trackpad things. They're good in a pinch, but I wouldn't want to use it every day. Let me see if I can't get this to have a slightly thicker font so you can see it. Appearance, monospace, allow bold text. Looks like I'm not going to. Well, I can change the background to white. And then put the text to black. And maybe this will look a little bit better. Hopefully you can see that. If not, maybe I can fix it in post. Alright, so I'll do a, let's see, I'm just going to go into permanent root mode. And DMESG, pipe that to more so we can go through the boot messages here. This is what came up on the screen when it was loading. Serial IO. Okay, come on. Okay, so SCSI was initialized. It found the SCSI card here. It found the Iomega drive. So that would be SDA. That's going to be this device here, SDA. And I'm just trying to see what it may have found as it was booting up, because it was actually going through this as I installed the media. SDB, or SDB, where is it finding the other SCSI device? Oh, okay, it's the USB drive, okay. Yeah, I like how Linux remaps stuff to certain devices. Anyway, I'll do an fdisk /dev/SDA. And it says, note, sector size is 256.512, and floating point exception, it crashes fdisk. So another fdisk that's on these systems is cfdisk /dev/SDA. And you notice it's actually reading things. Of course, it's going to change the colors on me. But it shows here, SDA4 is a FAT16 partition, so it should run in Windows or DOS. Iomega, it says the size is 21.42 here. But it shows up as 10 elsewhere, so maybe there's just some math going on that it's not, compatible with. So I know SDA4 is the partition name, so that's the device name. It's labeled Iomega. It can read the type. It's bootable actually, but I wasn't able to boot from it because I don't think I can boot from SCSI on this system. Anyway, so I'm going to go ahead and quit this. So I have, it's dev/SDA4, so hit enter. Now let me try to mount it. First I'll just make a directory in the media folder. I'll call it B for Bernoulli. And then I'll mount /dev/SDA4 to the media/B folder. And it says special device dev/SDA4 does not exist. So it's there, but it's not there. Something's different with it. So, and when I got these, I must have gotten about 50 or 60 pieces of this media. And my general curiosity is, I want to know what's in it or what's on it. You never know. There might be some old software on there that people are trying to find, on archive.org or whatever. And if I have this stuff here, I like to, make sure it's available to other collectors or people like me that like to tinker with this old stuff or can't find drivers for something. So I do want to get this stuff read I mean, there's different ways I can do it. I could probably do a DD of this and send it to an image file, and then use a modern PC to and write some software to parse through there and try to extract data from it. I mean, the partition layout and the data layout is probably well documented out there. I'd rather just read it directly, because from here I can copy it straight to the USB drive and then look at it on a modern machine. But it is what it is. These are neat devices. I actually have 3 of these. One of them something caught fire on the main board, so I consider that done. Another one just has this drive, not the secondary drive, and this I can't use the secondary drive because I took it out of line. I could probably do that with other kind of cabling if I don't get the original card for it. And then my third one is this one. I might take one of these because it is a valid power supply box, and I might put a 5 1/4 inch floppy drive and a 3 1/2 inch floppy drive here to do grease weasel backups, flux backups and stuff like that, and having a nice self-contained case. I never had a dual case to do that, but that should be pretty easy. And I also got about 8 or 9 of these types. A couple of them with bad drives, a couple with bad power supplies, but basically they're just an external SCSI box with, you can change the SCSI ID number right here. And I have 20s, I have one 44 megabyte one, I have several 90 megabyte ones, a couple 150s, and I think a 230 that's in the box. I also have 2 230s drive only that are meant to be put inside of a PC that are brand new. They haven't even been used. They have all the original cabling instructions tied up. The 230s can read everything down to a 44. They can write everything down to a 90, but they can't read 20. So that's why I need these running in order to get data off of it. But this is kind of what these are made of. I'm going to zoom in. Sorry, I have my camera on a stand here, so I'll try to zoom in and give you an idea of what things look like. And of course, just for fun, here's a close-up of the display I was using. And let me get this back here without making it wobble too much. But this is some of the stuff I do in my workshop. And I'll probably have more videos in the future from my workshop. This is just my crazy place to do things. Or, as you may have noticed already, Commodore 128D, Amiga 4000, all stacked. I just switched keyboards for the machine I want to use. Here's my mouse for just the Amiga, and a power center and everything, and a few discs to play around with. This is where I go to get out of trouble. I go do my own thing and not get in any trouble. But all around behind the scenes, I have projects just waiting in the wings, literally. Like this tape player here, making sure that that's working right. Nice RioShack random one. I'm working on some stuff that I picked up from the consignment at Vintage Computer Festival East. I tend to buy the broken things and try to fix them. I think it's cheaper that way, and also, it gives me something to do. Anyway, thank you for watching this video. If you have any questions about the Bernoulli system, feel free to post in the comments below, or email me, or go to my website, vintagevolts.com. And you can also contact me on Twitter @vintagevolts. And I'll show you some more stuff in the future as I improve my access with this, or my ability to archive this data. I'll certainly make a video about it. Thank you very much for watching.